morning again. And yeah, after this very, very interesting applications that we just saw and some theory, now we are going a bit more hands-on about an overview of preCICE tooling and specifically what is new in preCICE tooling. Okay, the main part will be the new preCICE CLI command line interface, and then I also give a short, brief overview of some other tools which we have. So many of the tools, so the preCICE CLI, what is it? It is a new tool which you can install using pipx install preCICE CLI, and it bundles together different tools which we already had, plus also some new utility features. And yeah, so previously some tools had to be installed using a certain Python package and some here and there. Now they are bundled together and it's more easy to use them. And yeah, I recommend to all of you just install it. It will make your life more easy. And yeah, what you probably know is this previous command preCICE tools, which is now deprecated. Instead, use the new CLI. And so let's just go right hands-on. I have already installed it, and I'll just type preCICE CLI and get a list of available commands. And for example, we can type preCICE CLI version to get a list of our different underlying tools and also our current preCICE version. And now I will show first one new utility which did not yet exist, which is the case generation. So as you all know, we are doing this standardization process of the adapter configurations. And one of the benefits which we now get is if all adapters follow the same format, we can kind of easily generate stuff. In this case, based on a quite simple topology input file, you can generate your whole initial case file structure, preCICE config. Especially the preCICE config is quite complex, so for someone who is new into it, it can be a bit difficult to work with it. So you all have already probably your setups, but especially when you start with a new project, it can take a lot, can make your life a lot easier. So let's just take one look. I'll share the slides, you can just click this link. Otherwise also you can navigate to it yourself. So let's just open, again, Meta Configurator. But in this case, not to edit the adapter config, but to edit this new topology. So what we can see is we have certain, so on the left side, good point. Okay. Can everyone see also in the back? Okay, all right, so again on the left and right side we see the same content, but once as a text file. On the right we have this graphical user interface which makes it more easy to especially see properties which are not yet in the document. So we have participants. In our case we have defined two participants, one fluid and one solid participant using SU2 and Calculix. And we have a certain exchanging, for example, the force from fluid to the solid, and displacement from solid to fluid. So very simple setup. Now we can also already set up some more properties like acceleration or coupling scheme, but we don't have to if we don't set them up. The default values will be used. So if you already know about details, set them. Otherwise, for now, just use the default values. Now, once your topology is done, simply press this download button to download it. Now I'm taking my topology document and placing it wherever I want to generate my new case. And yeah, by default, we call it topology.yaml. So very simple. Now having our topology, we can use our case generation, which is preCICE CLI init. And now the message is saying, okay, everything worked. You can find the generated files at the underline generated folder, which now has appeared. And what we can see is a project structure following also the new guidelines of an application case, having our preCICE config, having 2 directories, one for each participant. Also, each participant comes with a preset adapter config, also following the guidelines. Of course, if you use some participant which does not yet follow the standards, you have to adjust the configuration. Obviously, the participants themselves are not implemented because it depends on the actual participant which you want to use. It just generates some simple template saying, okay, run your participant here, fill in whatever you want to do. For example, run some Python file. The main work which is done by the generator is actually about the preCICE config, which we can now take a look at using another utility. So let's enter preCICE CLI config. And so, yeah, there's some utility to format the configuration, okay? But what we are now interested in is the visualization, which most of you probably already have seen. It's now integrated into this tool also. So we can type, let's first go into our directory, and then let's type preCICE CLI config visualize. Let's define our output. We want a picture, and then the config name. Okay. Now we expect to find an image which we have, showing or visualizing the generated preCICE config, which, as expected, we have our fluid and solid participant. They are exchanging displacement and force. By default, it is using the parallel implicit coupling scheme. Of course, if you would have entered some other values, they would also be shown here. Okay. Now, what we already used to have is the preCICE config check command. We have now extended it by more logical checks. So what does it do? Without running your simulation, you can already run this command to check whether your config makes sense. Different logical or syntactical issues which might happen. So in our case, if we would run it, we would expect that it works, obviously, because we have just generated the config. And yeah, it would be bad if the tool would generate an invalid config. Just to demonstrate, let's introduce one kind of issue, like renaming our solid to solid 2. If we again run our check, now we will get some kind of issue, warning, error. In this case, second participant in a coupling scheme is unknown. Did you mean solid 2? So yeah, without having to run your simulation, rather use this utility to first find out some of these basic issues. Okay, then we also have profiling, which Frederick has mentioned yesterday. Probably most of you already know about it. Why would you use profiling? Mainly to identify coupling overhead. And how does it work in preCICE? preCICE automatically, for every participant and rank, creates a profiling file, depending on the current profiling mode, which is either off, so no profiling. By default, all the fundamentals are profiled. And there are also settings for all or API. Of course, if you profile everything, your files might become very large. And what the CLI now offers is utility to merge your different profiling files together into one big profiling document, and also to analyze. So also let's take a look at one example. Going into the prepared profiling folder and then we will take a look at the elastic tube example. What is the elastic tube? Just one visualization. We just have a tube which is elastic, and yeah, so let's just run it and then try out profiling. Okay, so let's first go into our solid participant and run it. And also the fluid. Okay, they are now coupled and they are exchanging information. And once the simulation is done, we expect, in this case only in these two folders, to have corresponding profiling files. If you have thousands of ranks, of course you would have thousands of files. Okay, it should be done in a few seconds. Okay. So now what we can see is if we would go into our fluid participant, for example, we find a preCICE profiling folder having a profiling text document, which is also new. Previously we used this JSON format, but in the new format we can always append information, which makes it much more fast rather than always replacing the whole document. That's the main reason for changing this format. In the same way, we find one profiling file for the other participant. Now, if we use preCICE CLI profiling, we get a list of profiling commands. The one that we are going to use is merge, which now merge the files. Of course, it can take a bit more time if you have many rungs and files. And what we now got is this new profiling.db file. And based on that, we can now run different analysis. For example, we have integrated this trace command, which will open a trace in the browser, where now we can see different information, like, okay, the average duration of a certain function is this and this, and so on and so forth. So we can then analyze it. Okay. Then, aside from the CLI, just a very short overview. Benjamin already yesterday showed you this adapter config editor to edit these adapter configs. I just showed you this, the way to edit topologies. So as you can see, this meta configurator can actually be used for all kinds of cases. And yesterday, also after the session by Benjamin, Jingya went to me and also said she has a complex configuration document. Can she also get this kind of GUI for her kind of case? So I'll just very quickly demonstrate how you can use the tool also for your own cases. So you just open the tool, and in her case, she has a Gizmo participant config, which we can open. And it's just a quite big configuration file. And right now, we have to mainly edit it by hand, which can be difficult because what do these fields mean? And now using this tool, you can go to the schema view on the top, and now in a very cumbersome way create your own schema. Or you go to the new schema button and simply infer it from new data. With one click, and all this data structure is now generated automatically based on the existing configuration file. Obviously, this only works if you give it a comprehensive configuration file. Things which are not there will also not end up in the schema. Yeah, and then, but you can also, of course, edit your schema by hand. Also, once you have this kind of, so what do we get now? Let's go back to the data view, and now we get this kind of graphical user interface to fill in our data. So we, also someone who does not have a config file which is complete or starts from scratch now has this nice graphical view to fill in their data. So just as a hint, if you have some complex configuration files, come up to me later during the poster session, and you can also use this kind of tool for your own data structure. Okay, then this artificial solver testing environment was already brought up during the course. Still, I just say one short sentence. So if you are working on your own adapter or want to test your setup without running all participants, but you want to simulate one of these participants, then use Aste. Come up to David, who can tell you more about it. And in the same way, we also have the FMI runner, which allows you to couple participants to ODEs, and everything which implements this functional mockup unit standard. If you are interested in that, also go to David. And finally, we also have the micromanager by Ishan, which allows to couple many simulations on a micro scale and to manage many simulations on a micro scale and then couple them together to one simulation on a macro scale. So yeah, there will be a poster session about it by Ishan. And that's it. Yeah, thank you.
Thank you, Felix. Who has a question? Yeah.
I wonder why the domain name is like separate from preCICE. It seems like it's a very coupled to preCICE. Like why it's not like just in the why there is this domain metaconfigurator.com. Why it's not like the part of the website?
Independent tool that we are also using in chemistry to generate a automated lab, and we are using it for preCICE to make it easier to edit preCICE configurations.
Yeah.
But it can be used in any domain to edit structured data or create data models. So it's its own field of research, and we are using it for preCICE, but it's not restricted to preCICE.
Okay, I see. Thanks.
Yeah, thanks for the talk. I like that there's some utility around preCICE configs, adapter configs. But usually I use my editor like Visual Studio Code. What do you think about the idea to write a plugin or to integrate some of the functionality also directly in VS Code?
That was already asked by someone before, and yes, we have it on the list, and it might come in some time. Yeah, it's not a immediate to do, but yeah, it's on my list, and it makes sense. Yeah.
Okay, nice.
More questions? No? Then let's thank Felix again.